Absolutely. Thank you. People are still trickling in, but we can get started. My name is Amandeep. I'm one of the founders and CEO of a company called Okera, a 2.5-year-old company. I'm not going to be talking to you about what the company does. That's not the goal here. I want to share with you data management best practices, and specifically in the domain of governance and security, and how do you scale that within an enterprise. Before I go into that, a little bit about me. Like I said, Amandeep Khurana. I live in San Francisco, work there, just had a little daughter, and she's actually going to be 8 weeks on Monday. Thank you, thank you. Small little family, the 4 of us with a dog, and then a foodie, love music. But why are we talking about data management? I love solving hard problems. That's what drives me. It's basically, if there's inefficiency somewhere, that's what I'm after. So if you look at my background there, before Okera, I was a principal architect at Cloudera. I led the field team there for 5 years. Some of the largest big data deployments have gone through my hands. Large-scale, multi-petabyte deployments, thousands of nodes. Before that, I was one of the first few engineers on Amazon's product called Elastic MapReduce, which some of you might have come across in this ecosystem. Also written a book on HBase. And really, like I said, inefficiency killer, love solving hard problems, and actually getting people to get value out of the technology. That's where I anchor. So focus for today. When it comes to data management, we're going to focus on data lakes in the cloud. Data management in general is a very broad topic, right? So we're not going to cover the entire gamut. We're going to focus on data lakes in the cloud. And we'll go through a few different conversations. We'll talk about what are the core tenets of a modern cloud-based data lake. What does it mean to build one of these systems? What does it enable in the organization? It's a little different from what's in the data center. So the core tenets are a little different. So we'll cover that just to anchor the conversation. And then we'll go into the data management topics after that. Like I mentioned earlier, this is not a company pitch. I'm not going to be talking to you about what we do, our product. I may talk about other vendors in the mix. That does not mean I'm endorsing them. That does not mean that their product is a good product. I'll be only referring to them, if I do, in the context of the concept, the approach to solving a certain problem. So it's not, if I say Tableau, doesn't mean Tableau is better than their competitor. That's not, don't interpret it that way. All right, so let's start with the core tenets of a data lake. So the first thing I want you all to grasp here is data lake is not a technology stack. Contrary to what most people believe, data lake is not a technology. So the vendors will come in, and I used to work for one of those vendors. I led the team there. The say, we provide you a data lake. That's not how you want to look at data lakes. Data lake is a capability. It's a set of things you want to enable in the organization. In the cloud, what are the core tenets of a data lake that enable this capability? So firstly, it's a separation of storage and compute. That is one of the core tenets of it. What does that mean? The way you store data, where you store data, how you store data, has nothing to do with how you compute it. Right? It's a separation of those two systems. It's a separation of those concerns entirely. People who manage the storage are different from people who compute on data that is stored. They should scale in. You should be able to add or remove systems at either of those tiers independently. Making a change at any one of these layers should not affect the other one. That's what it means, separating storage and compute. And regardless of whichever system you use at either of these layers, whatever storage system might be, whatever compute engine you're using, you want to have a consistent set of functionalities. That is what I mean by the separation of concerns. So the same catalog, the same security, same auditability, same user management, et cetera, et cetera. Building in the cloud means that you want elasticity. So like I mentioned, you should be able to scale both these layers independently, so they're elastic in nature. Multi-tenancy is important when you're looking at data lake in the cloud. and trying to enable that. That's important. These next three pieces are incredibly critical. You want flexibility in the compute tools. So what does that mean? Some users will use Python, others will use Spark, others will use SQL engines, some will use just BI tools because that's what they're most comfortable in. Depending on the workload that you're trying to solve for, you'll pick and choose the tool that's important to you. You also want flexibility in the storage system. Like I mentioned earlier, you can add and remove as you see fit. So whether it's Amazon's S3, it's HDFS, it's a relational database, you want flexibility in that tier. You also want flexibility in the infrastructure. That means that you may be deploying in EC2 in AWS, or data center on static servers, or in Azure VMs. You shouldn't be limited by the infrastructure. When we start to look at these capabilities in the cloud, you want to be able to dynamically onboard new users and workloads. Right? So that shouldn't need a whole lot of engineering time. And last but not the least, and an incredibly important one is a data lake in the cloud for the enterprise needs to be secure, fully governed, and monitored. And so you need to be able to have very deep visibility into what users are doing, control what they're allowed to do, and monitor everything that's happening. Not because you want to prevent them from doing things. You want visibility there. You want predictability. As I go through this, if there's any questions, if something's not clear, please stop me, because we're going to build on one thing after the other. So what's cloud versus data center? What's different? When you're deploying in the data center, you're looking at it as a server-based view of things. You've got a bunch of servers, and you deploy things on those servers. When you're deploying in the cloud, you don't think servers, you think services. So it's a services-based view of the world. Now, when you look at the server world, you look at vertically integrated systems. You deploy a thing on a server. When you look at a service-based view, you're actually decoupling things. You're deconstructing the stack, right? Including your platform. The data warehouse gets deconstructed. That's the entire big data ecosystem. It's like separation of storage and compute. You're deconstructing the entire analytics stack. Scalability in the data center is static. In the cloud, it's elastic. You can scale up and down. The reason you go into the data center versus the cloud, well, data center is more of an old way of thinking about it, but you have to plan upfront in terms of your financials. Cloud is pay by usage. And this is an interesting one. The decision making in the data center is centralized to the IT team, but the decision making in the cloud world is in the hands of the end users, the businesses. That's a very key distinction there. And that reflects in how you think about data management. So let's talk about data management considerations. There's a lot in the scope of data management. Like I mentioned, we're not going to cover everything. So we'll cover the highest or the most important pieces that are the foundations of solving a broader set of problems. So we're going to talk about metadata management. We'll talk about authentication. We'll talk about access control, obfuscation, tokenization, and things like that. We'll talk about visibility, auditability, and then there's a bunch of topics that I couldn't fit into any of the first four, so I said miscellaneous topics. So metadata. I'll just talk through very high-level concepts of metadata, and it's important to get these right, at least get an understanding of it, so when you think about metadata in the organization, you build with the right foundations. So the first piece is technical metadata. Actually, metadata can be thought of in three different categories: technical, operational, and business. Technical metadata is things like schemas, file locations, sizes, who owns it, et cetera, things like that. That's just about technical information about the data set. Operational builds on that. Operational is what kind of transformations are happening on this particular table, what queries are running. So really, what operations are happening there. How fresh is it? How is it performing? How many rows per second are we able to read? Timing being, when was it accessed, and so forth. And then to build on top of that is the business context on the data, which is the semantic meaning behind the things that you're storing there. So what are the access policies? What context did it come with? What context is it allowed to get used with? And if you think about things like GDPR and consent management, there's a lot of context in there. So that's the business metadata piece. What are you allowed to do with something? Tags and so on and so forth fall under that category. So now we'll go into talking about pitfalls and best practices. Wrong ways of doing things and right ways of doing things. So a lot of people, when building data lakes in the cloud, you'll hear them say, let's get a crawler to find sensitive information in the data lake. Crawler to find data that's existing in the data lake. And then let's get a catalog to classify all of it so that we can govern it, right? And they start with that way to solve metadata problems. That's the wrong way of doing it. You have to build the foundations. You have to solve your technical metadata management problem first. Crawling and finding sensitive information is an operational piece, is a business metadata piece. This is sensitive, don't use it for so-and-so use case. That's a business metadata problem. Unless you have your technical metadata foundations right, that project is going to fall flat. So you want to think about metadata holistically. So technical, operational, business. That's how you want to think about it. If you go the other way, or you think about technical later on, it becomes pretty expensive to actually peel back from it.
But in a lot of situations where you get pulled in, you get pulled in because the wheel just fell off, right?
Yes.
So all those bad decisions have been made.
Yes.
You have to go in and somehow, unfortunately, you start with that.
Absolutely, you're right. But you still, when you solve that, you solve it, build the technical foundations, and then layer on top of it. So let's say you say, oh, we've deployed, I don't want to take vendor names, but we've deployed the system to go crawl and fingerprint data. That'll tell us where's the social security number. Great, fine, it's useful, but it's not working because the foundations aren't there. Let's build the foundations, it'll start working. Another thing that you'll hear people say is, it's schema on read. Just put stuff into the data lake. It's fine, schema on read, we'll deal with it later on. It's true, it's schema on read. It's absolutely true. That's what gives you the flexibility. But it says it is schema on read. Schemas are important. They're not optional, right? Your data consumers can't understand the data without a schema. You have to put a starting point for them, right? You don't skip it. Schemas are what enable multiple users to work with the same thing. That's how the description is given. So sure, it's on read. That's not a problem, but you need it. Let's talk about where metadata is stored. So you'll see a lot of people will build systems where they'll say, I have a Metastore, or I have a metadata engine, Metastore for this engine, one for that engine, then I've got this third one, and then we're going to sync between all of these because all of these systems have their own Metastores. Happens all the time. The longer you've been in your journey of building a data lake, the more Metastores and the more syncs are going on. That's a recipe for disaster. It's a complete disaster. In a lot of cases, people will say, well, I've got one database. I'll just enable everybody to read that database for metadata lookups. Yeah, I see some heads shaking. Bad plan, bad plan. You want to have one single database, sure, but put an API layer on top of it that enable multiple users and multiple workloads. In the world of big data, we call it the Hive Metastore API. Right? So have one Hive Metastore API that will serve the different engines. And when you do that, you have to then worry about user management and so on and so forth, which will build on this. We're going to talk about that next. This last one, I've actually come across this one, where this is a real-world example, where this is a 2 petabyte data lake, and so there's plenty of data in there. Ingest coming in, 100 gigs coming in every day, and I asked them, how do you know what exists here, the 2 petabytes? Do you have some way of knowing what is there? They said, yeah, here's a wiki page. Every time you ingest something, somebody goes and updates the wiki page. That's where the schema is. I said, and how frequently do you run into problems with that thing not being up to date? Yeah, every day. And then the analyst goes in and reads the thing and actually updates it. Come on. Wrong way of doing things. And then the other solution that people come up with for that is, well, I've got a bunch of shit, crawl the lake, create the metadata. Again, bad plan. Get a Metastore and integrate it into the workflow. Every time you add a partition, update the Metastore. Not wait for a wiki page to get updated.
Kind of saying tag it as you ingest the data.
Yes, at least at the basic level. But you don't have to have the richest set of metadata day one, but at the basic level, tag it that it's coming.
So are you, well, technically speaking, are you saying that doing some internet?
Yeah.
There's schema on it, but at least give me some basic.
Yeah, give me some information. I can transform it, I can create derived data sets, and I can do any number of things. Don't lock me into it, but give me some information. Get me started. And the more you give me, the more productive I will be. And oftentimes people don't have all the information, that's fine. But build it into the workflow. That's the key piece, is build it into the workflow. Think about it up front as much as possible. Let's talk about authentication. So if you have a single Metastore, you need to be able to have multiple users talking to it. Authentication becomes important. What you'll notice when people are building these data lakes in the cloud is the source of identity suddenly becomes this IAM thing that AWS provides you. Right? Wrong way of thinking about it. IAM gives you ability to control access to services, not to the data. It's not built for that. As much as the cloud vendors might tell you that you should use it for that, that's not the way you do it. And there's multiple reasons for that. We'll talk about it as we build on this. Active Directory, every enterprise has it. Single sign-on systems, that's what they do. Identity management, plug into those. Why do you want one more? Right? Single source of truth for identities. Otherwise, you're dealing with the same sync problem and inconsistencies. Authentication done at the granularity of IAM roles is why I don't like IAM. So multiple users will get the same IAM role, and they'll authenticate with the same IAM role, which means you actually have no idea which user came in and what did they do. You can't map them back to the actual individual. So if something goes wrong, or somebody asks, what did that user do? You have no way of providing that visibility. So that's a problem. Do it at the user and group level with Active Directory. System has worked for decades. It still continues to work. No need to reinvent the wheel. Authentication protocols. So you'll notice in the data lakes, in the data center, people love Kerberos. That's the thing that everybody uses for authentication. It's not built for the cloud. It's technology from the 1970s and has not evolved. It's not built for the cloud. It is built for static infrastructure. In the cloud, this is what single sign-on systems do. Tokens, OAuth, SAML, that's what that is all about. Use that mechanism. Don't use old world technology, because you're going to be in a world of pain. As infrastructure goes up, comes down, you scale up, you scale down, Rose falls flat very, very quickly. So building on that, access control and obfuscation. So now that I know who is accessing it, what are they allowed to see, and what is their view of what they're allowed to see. Don't use IAM-based access policies. Right, now this is very specific to S3 and AWS. Don't use IAM-based access policies or IAM-based policies to do access management. Very clunky, very hard to manage, error-prone. The granularity is not there. You will not have the visibility you need. Do role-based, based on Active Directory. You'll have to do some engineering to make that happen. That's the right way to do it. Where do you define these access policies? Do not define them in the storage system. Remember separation of storage and compute? If you define access policies at the storage system, you can't separate the concerns. You're locked in. You're limited. You define them in the compute engine, you're limited. It won't apply to a different compute engine. So you can't separate storage and compute. You lock yourself into one of them. The flexibility goes away the moment you do it at any of these systems. Focus on access policies at the data level. Data access policies. Right? GDPR says general data protection regulation. It does not say platform protection regulation. It does not say compute tool protection regulation. It's data that you're dealing with. So access policies are access to data. Build a policy engine that is independent and works agnostic to the storage system, agnostic to the compute engine. Remember, I mean, some place where you define policies and different granularities of defining those policies. So, who can see this table, this column, what is this user allowed to see, Is it anonymized or not? Things like that.
Would you consider Ranger as an example for
That is an example, yes.
policy?
Yeah, yes, yes. As a concept,
As a concept,
that's a good.
define the policy role.
Correct.
You could assign groups and all.
That's right. That's right.
You write it down on the paper or you write it down on top of our
Now, Ranger as a tool, it's an open source tool, is an example. So there's another one called Sentry. It's another example. Now, they're not complete in any way because they don't necessarily enable you to enforce across systems, but the idea, the concept is that. Who owns these policies? Now, this is a broader topic of data governance and data management. In the data center, what everybody is used to is there's a central governance team, right, that sits within the IT organization generally. But when you start to deploy these self-service systems in the cloud, you want to distribute your stewardship. So as you scale, it becomes very difficult for a central team to keep up. You're trying to do self-service. You can't have 5 people in the middle for self-service. Right? That's not how it's going to work. So you want to start thinking about distributed stewardship. What does that mean? The owner or the producer of the data that has published it into this lake, again, the lake is a capability, has published into the lake, is responsible for stewarding it. Access policies, auditability, quality, making sure it's there, freshness, updating the metadata, et cetera, et cetera, et cetera. They're responsible for it. Distribute the work. That's what's happening in the world of cloud anyway. The way to handle access control and obfuscation, you'll see that in some cases when you're trying to do access control at a finer grain level than files, and files today are usually the finest, finer grain level than files, people start to create these slices for different users. So my data set has 10 fields. This is a copy of it with 5. This is a copy of it with 3, and one of them is anonymized. This is a copy of it with 10, and so on and so forth. You need to do that for, like I mentioned, fine grained access control. You need to do that for regulation requirements, contractual obligations, and so on and so forth. People have to do that. That's the wrong way of doing it, because it gets very hairy very quickly, and you can't really manage those copies, and your cost also goes up. From an obfuscation perspective, I've seen people take a few different interesting approaches. So one that's actually pretty reasonable is obfuscate data and then store the entire thing. And it's fine if you don't care about the full fidelity data, which might be the case for your use cases. It's okay if that's the case. Take that approach. It becomes a bit of a security nightmare to do that, right? You obfuscate it, and if you care about the full fidelity, you have to keep the key somewhere. Again, 2 very real-world use cases that are there on the slide. I've seen people say, we obfuscated it and then threw away the key. So we have no way of actually decrypting it anymore. Why do you have it at all? What value does it provide? Again, let's look at GDPR. If your user ID is obfuscated and the user comes in and says, don't use my data for so-and-so thing, and you don't have the key, you can't do anything with it. Right? You're in trouble. Worse is hard code the key into application code so that it can be decrypted on read time. That's also happened. I've seen that also play out. I don't need to talk about why that's a bad idea. Right? So the way to solve for this is store full fidelity control access on the single copy granularities. On top of it, obfuscate on the fly, make it use case specific. That's the right way to solve that problem. That's the only way you'll separate out storage and compute. Otherwise, you'll be stuck. Yeah.
Doesn't GDPR want you to store it also securely?
You want encryption at the file system level. So if somebody takes your disk, they shouldn't be able to just read the data in there. Yes, file system encryption is important. I don't know if that's a part of the regulation, though.
It is ambiguous, but I think it does call out that you will make sure that data is safe and secure.
Yeah. Sure. So encryption at rest and encryption in transit is fine, but you decrypt it at read time. Otherwise, the data is useless.
So then are you saying unobfuscate every time?
Obfuscate at read time. So you're storing, you have file system level encryption, but when, let's say I'm one of the consumers of the data and I'm reading and I'm not allowed to see the social security number, obfuscate that for me. But maybe you're the admin and you're allowed to see it, so you don't need it obfuscated. That's a decision based on the user and the workload. Let's talk about auditability and visibility. Now, audit, I use the word audit because it's well understood, but the goal here is visibility into what's happening in the system, and that visibility can be applied for different things. A lot of people will architect systems and say, we'll deal with the audit trail later on. Let's get everything else going. Audit is not a problem right now. We'll deal with it later on. There is no audit to be built after the fact. If you don't engineer into the system upfront, you will never have visibility into what's happening. Audit, authentication, and access control go hand in hand. Things go hand in hand. They're a function of the metadata system that you build, or they're an extension of the metadata system you build. So those are not independent things. Don't say, oh, we'll build one, then the second, and the third, and 3 years later we'll build the fourth one. That's not how it plays out. This is another interesting one. I got audit covered. I've got Cloud Trail logs. My Elastic MapReduce gives me a bunch of logs. I'll put it together and I'll have all the visibility I want. No, audit is an always-on capability. You want to, at any point in time, be able to ask the question of the audit trail. And if you haven't really gone through creating these reports and seeing the granularity at which these reports are available, you'll likely not be able to do it when you need it. So build it into your architecture upfront. I've also seen people try to do this, where they say, chargebacks is the example that I'm taking, but that's not, the intent is not to talk about chargebacks. Let's build for this particular use case of audits, just for that particular use case. That's the wrong way to think about it. Build the foundations, build a rich audit trail system up front, and then you can have multiple use cases on top of it as you see fit. And you'll build on those use cases over time. Don't solve for a use case, solve for the platform. Now we go into these miscellaneous topics. So I talked about distributed stewardship. And the stewardship is not just from an access control perspective, it is just in general of stewarding your data assets in the enterprise. Deletes and updates is a data management issue that in the world of data lakes everybody runs into. Because data lakes are immutable and deletes and updates become very, very hard. What I've seen people do is a few different approaches, but the most common one is I've got a delta that's come in, I'm going to read the entire partition, I'm going to read the entire table, and update whatever I need to update in that and write it back. Imagine doing that at petabyte scale. Right? GDPR deletes, right to be forgotten. You could have arbitrary number of people coming in and on any given day and exercise their right to be forgotten. And you've got a 4 petabyte data lake. Good luck doing that at 4 petabyte scale every day. You will not complete it at any point in time. It's just never going to happen. I've also seen people say, let's build our data lake on a NoSQL system. HBase, Cassandra, Kudu, DynamoDB, whatever it might be, because they support deletes. No, those are not meant for analytics. Don't use them for analytics. It won't scale, it won't work, it won't perform, it'll fall over very, very quickly. So build views on data sets in the data lake and reconcile at read time. And then compact stuff behind the scenes periodically, every 3 months, every 4 months, whatever it might be for you. And turns out that's what databases do under the hood. Right? So you have to do that in the data lake also. We briefly touched upon the technology choices piece when I said that data centers are more server-based and vertically integrated systems. In the cloud, you want to think about things as capabilities and services. So pick and choose technologies like that. Lift and shift doesn't necessarily work always. In fact, it rarely works. Your technology from the data center will not necessarily work in the cloud. Some may not. But build services and build capabilities. This one is actually pretty common, where people say, oh, we can just build this thing. We'll put 4 people on it. How hard could it be? Yeah, it turns out these things are not easy to build. Not all of them. Some are easier than others. Not all of them are equally easy to build. Focus on your core competency. That's the entire thing about the cloud, is services, consume services. Build on top of those services. Focus on your core competency. Buy services and products that will enable you to go do that. You'll end up being cheaper and much more efficient in the long run. All right, so let's summarize. Cloud and the separation of storage and compute is a very powerful paradigm if you use it right. If you think about it as cloud is equal to an extension of the data center, you'll likely not use it right and will be in a world of pain or not get the benefits of it. Think about data management holistically. I only touched upon data management topics in the cloud. Data management is a very broad topic, so we can't really cover everything. But think about it holistically. Approach these as capabilities and services, not as servers and software I'm going to buy. Right? You're building services and capabilities, and build the foundations first. I can't stress on that enough. And then use the right abstractions and frameworks, like the policy engine, to solve the problems that they're best at. And I'll leave you with this. If you're able to scale governance and data management, you'll enable self-service and agility. It doesn't come in the way of agility. It doesn't come in the way of self-service. It is what enables self-service. Having 5 people in the mix is actually exactly the opposite of self-service. So find a way to scale governance and data management so you can enable your self-service and be agile. That's what I'll leave you with there. That's all I got. Thank you. I think we've got about 5 minutes.
Any questions?
Yeah. Any questions?
Yeah, I see you have like a like data security policy there, government policy. How do you enforce it? Say like we don't allow this person to access or don't allow this person to access. How do you enforce it?
There's a few different approaches that people take. One is they build the enforcement logic into each compute tool. So Ranger is like that, which is Ranger will give you policies, and then it'll give you plugins for the different compute tools on how the compute tool will enforce it. That's one approach. There's trade-offs to each approach. So there's a trade-off there that you're doing security in the user land. That's one. Secondly, as you add compute tools, you'll have to build that logic every single time. And thirdly, not all compute tools have the ability to do that. It's a Python script running on my laptop. There's no enforcement happening on my laptop. Right? So there's a trade-off that you make there. Second approach that you can take is you can build a data access layer, which is doing the work of enforcing for you. And then your different engines, different compute tools will access to the access layer. That can give you consistency.
Does that access layer is any software to do that?
Sorry?
Any software to do that?
I mentioned I will not go into the product and vendor stuff. There are capabilities out there. There are certain vendors that are building. We are one of them that provide that. And there are some open source frameworks that are trying to solve some of these problems as well. So there is capability being built and available. Yes. Yep. Yep. Sure.
So are you suggesting like because they do the compaction behind the scene?
Yes.
Are you suggesting like when you get a delta from a legacy system like Oracle, put the delta at real time, then you do the compaction in a different process?
Correct. Correct.
You do the manual changes rather than relying on
Right. So let's say you have a data lake in S3. Kudu can't do any compaction, right? You could potentially use Hive for some of that. The challenge with using Hive for those things is exactly. But yes, I'm suggesting that. Yes. So you have to build some logic into your data management frameworks. Correct. I was saying data lakes in the cloud. I specifically said we're going to talk about data management for data lakes in the cloud. Yeah. And also, Kudu is, remember separation of storage and compute?
Yeah, you run into the same problem with
So you're making a trade-off. You may as well be in a Teradata environment if you're going to be in Kudu. What's different? Fine, it's a little more scalable. Big deal. Now we're getting recorded here, and Todd's going to listen to this and not be very happy that I said it. But that's kind of what it is.
No, because even the data nodes and the compute stays in the same node.
Yeah.
Same with Kudu Capture server, same.
Yeah.
You run into the same problem with compute storage.
Yeah.
I know that it's probably like use case and implementation specific, but generally speaking, from the audit perspective, what level of lineage tracking or what guidance could you give about the need to maintain lineage and at what level of detail?
As detailed as you possibly can. So you want it at the level of how many rows, how many columns, which user, what time of the day, what tool, what IP address, just how many rows did they access, what was obfuscated, what was not, what query did they run. Because you could be asking any kind of question of the audit trail.
What about lineage though from a transformations perspective?
Yeah, so if you capture the query, that's the building block to go solve for the lineage. Yeah.
With reference to GDPR, data deletion, I have a lot of data within S3. Traversals take quite a long time to find all the data for an individual.
Yep.
Without having to restructure the data as the eventual project that'll happen.
Yep.
Rather than having an index, whether elastic or dynamo DB with various pieces. What do you think about that? Does it make that traversal, that finding, moving your data quicker?
So, see, the likes of Elastic, etc., are essentially a search engine. You still need a way of managing the metadata under the hood that the search engine will consume and work with. So if you have a bunch of data in S3, having Elastic will not solve for searchability.
Well, you mentioned the crawling and indexing that as a cache.
Oh, for sure, for sure. I mean, you can have multiple kinds of systems to have that index. Elastic is a very reasonable approach. Yeah. All right. Thank you. Yeah. Yeah, sure, go ahead. Oh, thank you. Thank you.